Hi everyone, this is Dr. Ino, your instructor for this course. I'm very happy that we have reached the end of the term and so we have our final exam posted. So I will provide a tutorial on how you can do your final exam, but also this tutorial will help you to remember starting from the continuous variables up to the end. So you can see that there was an announcement which I posted today, which informs you that I have posted this final exam and it must be completed not later than Tuesday 11:59 p.m. and that will be next week. And so I mentioned that I'm going to record video tutorials to demonstrate how you can approach each question, and that is part of the review. So unfortunately, we had a party yesterday and I had food poisoning, unfortunately, so I had to go to see the doctor, and I'm trying to settle in, and that's why I'm recording the videos right now. So I'm sure you have seen my this message, because I also send email to let you know that I'll not be able to be in class today because of the situation. But we had decided since Tuesday that we will not have exam in the classroom. Those who selected to do it in the classroom, I apologize because I wasn't able to be there. So we are all going to do this exam online. I'm encouraging everyone to do this exam, even if you know that you have enough points, and if you make mistakes, I will take your points to fill in. So it is a kind of review, so I want you guys to make sure that you do this exam regardless whether you have enough points or not. So given this announcement, then let's go back to the exam itself. So exam is posted in the assignment, and that will be our last assignment, which is final examination. And so if you can open it, you will find that this exam is in Excel. So here is the exam. It is actually attached, and so you can open it. And this is how the exam looks like. So let me start from the beginning. So we have the front page, which shows that we have applied statistics, and this is our final exam for the year 2025. And you are required to answer all questions in each section. Each section has a number of questions which are not really difficult. They are easy kind of questions, I can say. So we'll start from the beginning. So we have normal distribution kind of questions. We have sampling distribution of a sample mean, and then we have confidence interval, hypothesis testing, and finally we have simple linear regression, or I would say linear regression. That was our last topic. So let me start with the last question, where we have a number of students, and these students have two exams. We have third exam score and final exam score. I think this one is out of 100, and the other one should be out of 200. Yeah, explanation is provided here. So what we are required to do is to see if there is any relationship between the third exam score and the final exam score. Let's say you had good performance in the third exam. Will you have the same performance for your final exam? Does the final exam depend on what you have scored in your third exam? In this case, you can see one variable must depend on the other, and therefore we can say that final exam score is a function of the third exam score, meaning that anything happened within the third exam score will actually affect your final exam. So I'm not going to deal with this. I'm going to open an example of which I will address all these kind of questions, and so you can do the same for this exam. Those who were not in class on Tuesday, you will get the opportunity to know how to deal with this kind of questions. So I'm going to open example that we had. So you can see that we have the last topic is regression analysis. And if you open this, you will see that we have a number of files which were posted. And height and weight example, where we have two variables that can relate it to what we have in our final exam. So let me download this file, enable editing, and I'm going to put this on this side. So you can see in our exam we have 11 students, and we have their performance for their third exam and also the performance in their final exam. So these are two variables, same as what we have here. We have height and weight. And remember I told you that here we can say final exam is a function of the third exam. Final exam score is the function of the third exam score. So in this case as well, I will say weight is a function of height, meaning that your weight will depend on the height that you have. So I'll say weight is a function of height. That's the theory, or that's the assumption we have. We think that your weight is a function of height. And this follows what we discussed in class, given that you have y and x, and y depends on x. So we could say y is a function of x. And so in this case, weight is y and x is actually the height. And we need to create hypotheses, as we discussed before. So we're going to have the null hypothesis and also the alternative hypothesis. In regression analysis, we consider the slope. In other words, we can say if height changes by a unit or per unit, by how much weight will change. And so weight will change by the slope of height. So, and I'll show that when we create our model. So in this case, we will say the slope, which can be written as b, and in this case we can say the slope equals to 0. So it means that there is no slope in whatsoever when you change height in relation to weight. So if there is no slope, then that means if height changes even per unit, weight will not change by the change in height. It will either change for something else but not the height. So that is what we say slope equals to 0. And remember, we have to provide it the confidence level or the probability of the null hypothesis, which by default is 95%. Now, alternatively, we can say that slope is significant. It is greater than 0. We need to provide the probability that will prove that the slope is actually more than 0, meaning that if you change height per unit, weight will change significantly. So we need probability value which should be less or equal to 5% significance level. Now, we have responded to the first question, which is to state the hypothesis regarding the prediction of what we have. So I will expect you to do something like this. In this case, we know that the final exam will change by the slope of the third exam score. Develop something like this, and that is done for the first question. So if we can go and do part B, which says write the regression equation based on the data above. So regression equation, if you can remember, we said weight, let me do it here. We can say weight equals to weight can change without height changes. It is what we call y-intercept, the change that will happen along the y-axis and nothing changes within the x-axis. And so A will represent y-intercept. And we are going to add. So A will take any change in weight which do not depend on any change in height. But now we're going to add the change in height that significantly affect weight. And so we'll consider the slope of height. And we will add the error term. That's actually regression model. Now our estimation, so I'll say estimation. So we can do estimation here, where we will say weight. So in your case, you're going to have final exam score estimate equals to A plus B height. And we don't consider the error term because A plus the slope of height will give us estimation. So I will expect you to do exactly the same to show that the final exam score equals to A plus the slope of the third exam score. And so that's what we actually have to write for B. And once we have this, then we can run regression, which is part C. And let me do this. To run regression, you need to, if you're using Windows, you need to add in data analysis. So just click on the file, go all the way down, click on option, and so you get this. Don't forget to click on add-ins, and then don't click OK, but click go, and make sure that this is checked. Analysis toolpath. I checked the solver because I've been using solver, so that's why it is checked. So otherwise I could just check analysis toolpath, and then you can click go, OK. So now you have data analysis, but to see where is your data analysis, you need to go to the data here, click, and then you will see data analysis. Also I have solver listed, but all we need is the data analysis. Let's say you're using Mac. Mac is a little bit different from Windows. So what you have to do is to go to the very top ribbon and find tools. It should be there in the menu. Click on the tools and then go all the way down. You will find Excel add-ins. Click on Excel add-ins and check analysis toolpath. And then when you click on the data, you will see data analysis. And all I want you to do is just to open data analysis. And you have a lot of analysis tools, but all I want you to do today is just select the regression. So click on the regression and then click OK. And so you're going to have this table. Now, the first thing to do is to input the Y range. So you can see Y is our weight and X is height. So the Y range for me will be the weight. So I'm going to select the label all the way down, and that is my Y range. I have to input X, which is height. So click here, select height, including the label. And then make sure that labels, you select this box for the labels. Confidence level is 95%, which actually I have mentioned here. And I need my output to be somewhere around here, because that's what the question says. You need your output to be very close to your data. And so I'm going to select output range and click inside, and then you can show where your output should be. Mine should be here, and I want to have residuals as well. I don't really need anything else, and so I'm going to click OK. You should get these results. Now, the very first thing, or the things that you need to identify, are the multiple r and r squared. So let me highlight them. And then we need to get the coefficients. Let me highlight a little different. And finally, we need the p-value. So this p-value is for y-intercept. We don't really need it. So we need this p-value here. Let me highlight it as well. So those are the things which we need to respond to the question that we have. So here you are asked to run a regression analysis, and that is the outcome of the regression analysis. Now we move on to D, which says describe the following results. Find the multiple, describe the multiple correlation. So you can see multiple correlation. This is the correlation between two variables, height and weight. And let's prove if this is actually the correlation for these two variables. When you are considering single regression analysis, multiple R will actually be the same as the correlation, which you can find by using Correl function. So I'll put equal sign there and type Correl, and I will select the first array and then put the comma and select the second one and close the bracket. And so let's see what is the correlation. You can see that this correlation is exactly the same as the multiple R which we have here. However, when you are looking at more than one variable, meaning that weight depends on height and something else, then the correlation won't be the same, because now we're going to have more than one independent variable, and correlation is only for two variables. And so when you have more than two variables, then that means the multiple R will be different from what we have found here. So now let's describe this multiple R, or the correlation of our regression model. This correlation states that I will respond here, say our correlation is actually more than 0.5, and so we can say we have significant positive correlation in our model. And let's look at the R squared. R squared, which is coefficient of determination, it shows by how much our regression model can explain, or our estimation can explain, this real weight. So in this case, we've done the estimation, this one, our weight estimate, and we'll try to find how close we are able to explain the weight by using height. So here you can see about 67% is explained, but 33% unexplained. So our estimate by using height, we could explain weight by about 67%. Only 33% is unexplained. So that is the multiple R and R squared. Now, if you go back to the question, you can see describe the following multiple correlation. So for this exam, it may depend either your multiple R could be significant or may not be significant. If it is not significant, there is nothing you can do. But if it is significant, then we have to consider the regression model. You are also asked to find R squared, which we have explained here, and try to find by how much your estimate can explain the real weight. How your the weight estimate could explain these real weights we have. Now, then we are asked to focus on the coefficients. If you go back here, you can see we have coefficients. And so we have y-intercept, this value here, and then which is A according to our equation, and this is B, which we have here. B is this value here. Remember, A and B are coefficients. So let me write here, A and B are coefficients, meaning that A is y-intercept and B is the slope. So now we know that the slope of height is 6, and we need to find if this value is significant. We need to find if this is significant, when here we said B, or the slope is not significant, but it is 0. That's the null hypothesis. But alternatively, we will say that the slope of weight is not equal to 0. And we will prove this by the p-value, which is less or equal to 5%. So if we can reject the null hypothesis, that means alternative hypothesis will prevail. And if alternative hypothesis prevails, then that means height has something to do with weight. Or I can say height significantly determine the weight. So come down here, you can see that our p-value is 3.13e-05. This is the exponential value, meaning that we are going to count 5 zeros and then 313. So this is how we can say this, the p-value here, 0.0313. And that means p-value is 0.00. Is 0.00 or 0, we can say. And this p-value is good because remember here we are saying probability value must be equal to 5% or less. And so probability of 0 is actually way less than 5%. So in this case, we will reject the null hypothesis, and our conclusion is the slope of weight, the slope of height actually determines the weight. So let's go to this question again. So here we're supposed to find the coefficients of y-intercept and the slope. So as I've said, A is minus 265.74, that's y-intercept, and that is the slope of height. Now we can rewrite this equation here, this estimated equation, by including the coefficients. So how do we write that? Remember, we're going to put these values in here, A and B. So we can say weight estimate equals to A, and our A is this one, so we can say minus 265.74, and then we're going to add. So the slope, which is B, is 6.14249, but we have to include to put the height there. So that is actually the equation which we have developed after we have our results. So let me highlight this. So I'm expecting you to rewrite your equation to look like this. Weight estimate. So we have A, which is y-intercept, plus 6.142449 times height. So let's see our estimations. So let's say we're going to change height per unit. So weight estimate will be minus 265.74 plus 6.14249, and we are changing height per unit, so we're going to put 1 there. If we change twice, it will be 2. If we change height 3 times, that will actually change here. So we are trying to find how weight will be when height has changed per unit. And so we'll put 1 here, and the weight estimate will be this one plus this one. So let me write it here. I'm going to put the values here properly so we can do the calculations. And then 6.14249, and so we're going to sum, put equal sign, sum, close the bracket. So we will add this 2. This is what we are supposed to do here. Add. Remember, 6.142449 times 1 is actually the same value. So if you can enter, you will see that the per unit change of height will change weight by 259.598. But we can do this way if at all the p-value is significant. And this p-value, if the p-value shows that the slope is significant. And what we have here, it is the p-value which is less than 5% according to our hypothesis, and therefore we know that this height is significant. That's what we have here. Like that. Okay, so you see we have our residuals here. So the first item, you can see that our height is 72 and weight is 200. So because our equation can explain only 67%, you can see that we have residual of 23.4835. So our prediction was not exactly 200 for the first variable. For this first variable, you can see it is 200, but our estimates or our estimation was very close to 200. It's 172 with the residual of 23, meaning that we underestimate the first value. The second one also we underestimate, but the fifth value, which we have 127.377, we have overestimated by 7.3768 which is the fifth. It is 120. That's the fifth one. 120, and our estimates give us 127. So anyways, let's go back to our exam. You could see that we are able to explain multiple R, or multiple correlation, R squared, and also we were able to explain the y-intercept and the slope. And also we were able to talk about the p-value of the coefficient, which is slope. And so the last question says, given the p-value above, do you think the third exam significantly determines the final exam? Yes, it does, because you can see that, as we said, our p-value is way less than 5%, and therefore the slope is significant. So let me see what you guys are going to do in your final exam. You can see you can finish this question as quickly as possible.